So this question says, explain what it means for a function to be one-to-one. And what does this tell us about a possible inverse function? So there's two issues here. The first issue is something has to be a function. And how do we know if a set of points is a function? It has to pass the vertical line test. Now, what does that mean? Let's take a look at our graph. If I have a function like this, no vertical line hits it more than 1 point. Notice you take a look at the line x equals 1, for example. It intersects in at exactly 1 point. So that's okay, that would be a function. Similarly, if I had y equals x squared, any vertical line is going to intersect this in at most 1 point. For example, if I had x equal -2. So that passes the vertical line test, that is a function. Something that doesn't pass the vertical line test would be something like this. You'll notice a vertical line x equals 3 intersects it in 2 points. So I think of it this way, 3 is the question. You can't have two different answers for the same question. So this is not a function. So to be a function, you've got to satisfy the vertical line test, which tells us that no vertical line can intersect the graph in more than 1 point. And as we saw with the last one, with this case, any x value can only have one y value. So there must be at most one y value for any given x value. Okay, so that's what it has to be a function. Now, to be one-to-one, what does that mean? Let's go back and look at our graph again. To be one-to-one, you have to pass the horizontal line test. This function here is not one-to-one because this y value, y equals 4, has two different x values, right? If the y value is 4, the x value could be 2 or -2. Now, this is a function. It's okay to fail the horizontal line test to be a function, but it is not okay to fail the horizontal line test to be one-to-one. So for a function to be one-to-one, what do we say? A function is one-to-one if any horizontal line intersects the graph in at most 1 point. So essentially what this is saying, if we go back and look at our graph, so this is not one-to-one. The same y value has two different x values. So to be one-to-one, any given y value has to have at most one x value. And to be a function, any given x value must have at most one y value. That's 1 to 1. One x value yields one y value, one y value yields one x value. One x yields one y yields one x. That's why we call it 1 to 1. Now, what do we know about that? If we go back and look at this y equals x squared, this is not 1 to 1 because a horizontal line will cut it in 2 points. Because if we would do its inverse, remember to do an inverse, x becomes y becomes x. This is what the inverse would look like. If x becomes y becomes x, let's change the color of that. So blue is y equals x squared. Red is x equals y squared, but would be the inverse. And you'll notice that is not a function. If x becomes y and y becomes x, this fails the vertical line test, so this is not a function. So the original f of x equals x squared does not have an inverse because it is not 1 to 1. And then what do we say then about this? If a function is 1 to 1, then it has an inverse. So that's our big fact. If a function is 1 to 1, which means any horizontal line cuts it in at most 1 point. And of course, to be a function, any vertical line cuts it in at most point. So if a function is 1 to 1, then that function has an inverse. So we'll just take a look at a couple graphs that would behave that way. So this is not 1 to 1, but y equals 2x minus 1 is 1 to 1. Then if we wanted to draw its inverse, x equals 2y minus 1. And normally speaking, you would solve for y. Notice that also satisfies the condition of the vertical line test. No vertical line cuts the green thing in more than 1 point. But you'd have to solve for y to see what that function is. Let's do one more sort of like that. How about y equals 2 to the x power? This passes the horizontal line test. Now it looks like this is getting closer and closer to the x-axis, but that's asymptotic. It never actually gets horizontal. So if I replace x with y with x equals 2 to the y, this black function would be the inverse of f of x equals 2 to the x. And notice, again, it also passes the vertical line test. It is a function. But if it doesn't pass the horizontal line test, then its inverse wouldn't pass the vertical line test. It wouldn't be a function, which is why we must have this requirement. The function must be 1 to 1. If a function is 1 to 1, then the function has an inverse. If a function is not 1 to 1, it does not have an inverse. That is our key idea.